2. This is the libembeddedhal ecosystems weekly meeting, and we're going to go over a couple of things. So, quick little updates and highlights. First one is still we have this one CAN bug driver. It's nearly finished. We just need to get like a few things fixed up with the documentation, and then we'll be good to go, and we'll pull it in. So it's nearly done to pull in. Just got to get the documentation ready, and I'll be available for anyone to use. Next item we're actually going to go over today is going through some of the commits. I decided not to like flood all of these slides with a whole bunch of the commit stuff. I'm just going to go through a whole list of the commits and why they're important, just so you guys can keep up with what's changing. I also want to talk about my meeting with Jason Turner. I thought it was a very eye-opening meeting, and I learned a whole variety, a lot of things that I need to improve on, fix up, and change in the code base. Not significantly, except for one area, this area right here. But yeah, I'll go into detail about some of the cool things that kind of came from this meeting, and when we get to this little blurb here. But I think one of the most important things I'm going to be talking about is the new initialization model. And I know I've been talking about the initialization model for a while. We keep changing it up all the time because I keep many of them have their flaws and their issues. But I think after my talk with Jason, he has convinced me that we really should be using constructors for this. And I've been trying to figure out ways to make this work in a way that makes sense. I sound a little funny is because I probably don't, but if I sound a little funny, probably because of the fact that I had some dental work done today, which will happen next week as well, and the next week after that. So next meeting will probably sound a little funny as well. So let's look over at some commits. Alrighty, so I'm going to scroll down to, I think last time it was January 19th when we had a previous meeting, so I'm just going to go from there. I already explained some of the changes to the CAN bus driver here, so I'm not going to go over that. Fix ambiguous access to platform string. That's just simply fixing the tweak file. I don't know if I've actually gone over the tweak files that much in these meetings. So before we used to use macros in order to determine whether or not a particular, and actually I'm going to look at this. I'm going to click on this. Let's go to the commit itself, or I can go to view file. There we go. So there's a config HTTP file, similar to how we had it in SJDev2, except in this case, you don't actually need to use macros or set up any macros inside of your build system in order to make these changes. Although you technically could if you wanted to, and I can show you how that's done. But here we have a whole set of different configuration options for libembeddedhal, such as what platform are you running? Do you want to be able to get a stack trace on error? Do you want to how deep do you want your stack trace to be? And then also, do you want to get store position information in there as well, such as line number, but also file name and function name. We also have a couple of helpers in here, like is platform, to check to see if this thing is a particular platform. It is checked to see if it starts with that platform name. For example, if you want to know that this thing's explicitly a LPC 4078, you can check that. If you want to just check to see that's an LPC 40, you put an LPC 40. And it is a test, just allows you to tell you whether or not it's a test or not. And then I may, the way that you would basically configure these is, I'm actually going to do a little edit here. Yeah. So the way that you'd actually configure this is inside of this file here. Oh, am I not able to edit? You must, what's the saying? You must be on a branch that has the, to make the, okay, so let's just go to main for this. Yeah. So inside of this actual include here, if this actually existed, it would become this. Oh, let's do that. Oh my goodness. Oh, the thing doesn't work like normal. All right, so let's say I wanted to change the name of the platform. All I would need to do is create embed config and just change this to LPC 40, and that's it. That's pretty much it. Nothing more to say there. That's all that she wrote. It's as simple as that. And that will actually override this. And it has to do with name lookup priority. Whenever you do like this using namespace in this particular context, the name priority will actually go here. The name lookup will go here versus going here. It'll use this as a backup. So that's kind of one of the interesting things that we have in libembeddedhal. Leave that. All right. So that's just that. In this case, we just fixed up some errors that were there. Added a new error to serial. Basically an error to indicate that the settings were incorrect. So we just have this invalid setting structure. throw this whenever, or create a new error with this whenever you want to signify that the error that the settings that you set for your UART are not achievable with whatever the system's set up as. So that's there. Overflow counter. This one's interesting. So overflow counter is, well, it's a way to extend the amount of count of a lower bitrate counter to a bigger bitrate counter. For example, do I have an? I don't have an example exactly here. If I look at the ARM Cortex code, I can actually see that example. But the main idea here is that the counter class requires that you return a uint64. The reason why is because at that number, if you even had a counter that was running at a nanosecond, it would last 514 years, a little bit more than that. And that gives you a good amount of leeway. Now, when you have a 32-bit number, it'll overflow if you have it running at 1 nanosecond within like 5 minutes. A way to catch this is that as long as you check the value soon enough or enough times within that amount of time, you can detect overflows. If you detect an overflow, you can count that overflow, and then you can basically use that count of overflows to extend the number from 32 bits to 64 bits. So it's a way to bring lower bit resolution numbers or counters or timers or whatever up to higher bit resolution numbers. Oh, and also, if you have any questions, again, like I've said before, just unmute and then just say, hey, I got a question real quick. Yeah, so this is a little helper class to make that logic for creating overflow or counting overflows easier, so that every library that needs to basically do that upscaling or be able to count overflows can do so without having to worry about writing the algorithm over and over and over again for each implementation. So that's overflow count. And actually, I can show you an example of how that's actually used. So if I go to lib arm cortex, I don't know if this is inside the main yet. I think it is. Yeah, it says right here, overflow counter. So you can actually see that for our count here, I just take the register, the count, cycle count, put it into update here for mcount, and that will then return back a uint64, and it'll help to determine if there's been any overflows. And I tested this out, and it works perfect. So waited like 5 minutes, or not 5 minutes, I forgot how much time I had, but I waited some time before the thing would overflow and showed that it does actually work. So that's cool. Rename driver reset to set as uninitialized. This is just a way to reset is used in other places where it makes a little more sense. So I removed that I changed it to be more explicit what that means. Couple of type defs in the time class. A couple of cleanups for timers where like the time, an error, basically for the errors specifically, the type is no longer delay too large or too small. It's now just out of bounds, which makes more sense. And it's also it reduces your type count by 1. Had some errors on initialized settings that I fixed up. Removed default parameters in SPI. Just want you guys all to know this. This is actually incorrect. Inside your interfaces, you should not put in default parameters because, and I've actually kind of known this before, but I put them here anyway just because I wanted that to be something that people follow. But I discovered that like this is actually just a code smell. It doesn't actually work very well. It only works for when you're using the class, not as the actual full class type, but as its interface. And the only way to make this happen for each stage of the interfaces in the hierarchy is to copy this line for the default parameter for each one of those. You miss it in one of those, it will not be there, which is an annoyance. So I just removed it because it just isn't helpful. And that's only for virtual. Virtual suffers that problem. If you have a normal function, then it's fine. Make interfaces conform to C++ core guidelines. I think I did this, and this is actually incorrect. When I talked to Jason Turner, he told me that what I was doing was actually wrong. Well, basically, this is unnecessary. I don't have to do this over and over and over again. But I did make the decision to make all the drivers have explicit deletion of copy and also of operator equals, and then I'm missing this here, but it also should also explicitly delete move as well. The reason being is you should never copy an instance of a particular driver, specifically I2C. Like in that particular case, there's only a few I2Cs, and copying them just creates chaos. So if you have two instances with different states for I2C, that's a problem. So deleting copy is the choice here, as well as also move. But maybe we discover that move is necessary in the future. I'm not sure, but that's something that we were thinking about. I don't think there's anything too much else here besides maybe some cleanup for some what I'm looking for. Kind of shortening down some of the comments. Yeah, that was pretty much it. Oh, and then adding override to this little area here. Okay, so that's that. Add utility functions for counter. So here's one of the bigger items. I probably should have made a slide for this, actually. This is actually quite important. I'm going to show you some of the utility functions for counter, but I'm also going to show you some utility functions for, where's I2C? I2C, oops daisy. I2C, SPI, serial. Okay. All right, so yeah, let's look at this one for a sec. Yeah, so I talked about utility classes before, or enhancement classes before, or wrapper classes. Those are kind of the terms I was using before. And I tried making one called enhance counter, and it just never really worked. It was a class that would wrap around, like you pass it a counter, and then it would give you methods for, or class functions for reset, start, a shorthand for reset, a shorthand for start, a shorthand for stop, as well as also a shorthand for getting uptime and a shorthand for getting sleep for, or like a way to like delay and stuff like that. But I couldn't come up with a name. Honestly, I really could not come up with a name. Enhanced counter sound dumb. It just didn't make any sense. Like, why is it more enhanced? It just has more things. But also, what happens if I make another one? Do I make an enhanced counter too? Like, it didn't fit. And eventually, after looking into some of the core guidelines, their recommendation is that you should just have, to expand the APIs that work for your particular class, you should make a free function. Make a free function, pass counter into that free function, and then have it just be called reset. So you do reset and then just throw into it counter, and then that will reset the counter. Also, same thing with start, same thing with stop. And the idea here is that you can also still do overloading here. So maybe there's some other object that we can start, stop, and reset, and we throw that in there, and they'll have different meanings, but they'll still have the same semantics no matter what you design. Same thing with uptime, a way to convert the counter's count to a count in a uptime in nanoseconds, which you can then convert into hours and minutes and whatever else. A common way to sleep using a counter, so you can actually use the counter in order to sleep for a duration of time, and as well as a way to set a global uptime and global sleep. The thing I wanted to make very clear here is that we didn't need to make classes. We didn't need to make all these fancy classes do all this. You simply need to just create a function that has some utility, does something helpful for you to expand what isn't currently available in the APIs, but is totally something that's possible to do with the APIs. To show you a little bit more, I'm just going to check to make sure I'm still online. Okay, cool. Because sometimes there's been times when I get disconnected from Discord and I don't know. Here, well, I2C just has one method, or one virtual function, and that is transaction. It takes an address, takes a data to spit out, and it takes a buffer to read in. And depending on which buffer is set to null, it will behave differently. For example, if you set both of these to null, then it doesn't really make any sense. It just returns quickly for you. If you set one of these to an actual buffer that you're going to write out, and then you set another one to a null buffer or an empty buffer, then it only does a write transaction. If you do just read, then it does a read transaction. If you do both, then it does a read and then write. And here we have a helper function that basically allows you to kind of shorthand this. You don't have to write in this empty span. You just put in the I2C, the address, and the data out. Same thing for data in. And then we have some other helper functions for read, so that you don't actually have to put in a data in if you don't want to. Like, you don't have to create another buffer, then pass that into read. If you want to, you can have this thing actually return you an array of bytes directly. So you just pass in the address and the I2C and how many bytes you want to read, and it'll return back to you that array of bytes, generating it for you. Same thing with read and write and so on and so forth. So that's what this does. And then some unit tests for it as well. Same thing with SPI. Same old goodies. A write, a read, a read that returns an array, and then a write then read, and then a write then read that returns an array. And then serial, similar. except now you have timeouts. Now you have to consider, making sure that how much time do you want to take for each one of these operations. This one's a little bit longer. We're not going to go too far into this. That is missing a new line. That should have, my Clang Tidy should have caught that, but maybe I don't have force new line as part of the Clang Tidy list, so I might need to add that in. But yeah, that's kind of the utility functions. They're no longer utility classes. They're now just utility functions. So that should be a lot easier for people to kind of wrap their head around. So if you were kind of looking at an API and you're like, it'd be really cool. Actually, here's an example. I don't have this yet. ADC, the analog to digital converter. It'd be really nice if the ADC, had a utility function that was called average, just called average, maybe it's average, maybe average samples, something like that. But the idea is that when you pass, an ADC into it, you can also probably give it like a template parameter saying I want 10 options, or maybe just a normal parameter like 10. And what it would do is it'll grab all the samples and it'll give you an average for 10. Maybe another one that like says I want you to return an array, but then you also say I want to average for 10. And I want to have an array of like 10 of those samples. I want to have 10 average samples over 10, cycles or whatever. Maybe even have like a timeout that you throw in there as well for how long it should delay between each one of these samples. I'm not sure how to really design that off the top of my head. I'm just kind of spitballing here. But that's kind of the thing, is that you can kind of add these new features on top of these APIs, and you don't have to worry about writing any drivers. You can just write you can write this, and as long as the driver implements the correct interface, then we should be fine. We should work just perfect. We'll stop here and ask if there's any questions or any comments. Make sure my audio's up. Okay. Cool. Alrighty. Let's move back down. A couple other changes. Oh yeah, this one's interesting. Slim down PWM interface. And before I get into that, I'm actually going to open up a couple more. That's just a bug fix. Default initialize all class members. Default initialize all class members. I don't know what that means. Check that out as well. No accept, just went through and made some no accept changes. I just upgraded leaf. I'll show one little thing here. And rule of 5, that's the proper fix. So there used to be a frequency getter and setter function. That's because with SJDev 2, the getter and setter were when you get the frequency, you actually calculated it based off of the register values. When you set this frequency, you set it to register values as you normally would. But I realized that like this thing is something that's actually kind of invariant. It can be anything, and it can also just simply be another setting. Like usually when it comes to PWM, you set the frequency at one point and then you leave it there. There are PWM implementations or like people who have designs that like require you to be able to manipulate the frequency. And I think in that case, we should actually make a new type for that. So we don't have to bog down a specific PWM driver with the complexities of needing to be able to track and, manipulate the frequency through a public API. But yeah, so really PWM just has duty cycle. That's it. Just how to set the duty cycle. And I even got rid of the return type because I didn't feel like returning back or getting back the duty cycle even made sense. So for now, we just have duty cycle. My face still hurts. Okay. Default initialize all member classes. What was this for? Oh yeah, this is going through and making sure that every member class for every driver that I could find had a default initializer, just so that this array has something. It's to make sure that all these values are properly initialized when you construct the object. So that's all I did here, is making sure that's there. It's a best practice to make sure you do that. Upgraded leaf. This is the commit message of the leaf commit that has this change. I'm not going to load leaf because I don't need to look at all those changes. But the main thing is that we used to have this thing called embed check, which would do GNU statement expressions. So basically this allowed you to return a value from a macro, which is awesome. I talked to the guy who worked on Boost Leaf, And he's like, hey, are there things that in here that I think that you think you would want to change, or any problems that you've been coming across? I'm like, no, not really. Just that I made this one macro, and maybe this would be cool for you to add in, but like you don't have to. And he decided, yeah, I want to add this in. I think this makes sense for us to add that in. So now boost leaf check now actually does statement expressions. So you can actually throw anything you want into boost leaf check, and it will return a value if the value exists. At some point, I'm going to get rid of embed check and just use boost leaf check everywhere. So that's the thing. This is just here in order to keep things compiling before I make the big refactor. And then finally, the rule of 5 is properly implemented. I'm deleting all of the excess changes here, except for one. I'm now explicitly deleting the move constructor in the driver HPP class. And you can see that here. It also comes with a virtual destructor. So yeah, that's all you really need. Everything else kind of carries over from the talk I had with Jason Turner. So yeah, that's pretty much all like the little updates. There's been a lot of code. I've written a lot of code for libembeddedhal in these last 2 weeks. Kind of just going like crazy on that. But any questions or comments on what we've talked about thus far, if anyone has any at the moment? Okay, let's move on. So I had my meeting with Jason Turner. Well, actually, let me get my notebook because I went over a lot of things with him. So Jason Turner, if you haven't seen C++ Weekly, you should absolutely be watching that. It's a great resource for learning C++, getting into the details of the language. He does on-site contracting and training and stuff like that. And I asked him on Twitter if I could get like a 1 to 2 hour session with him. And he said yes. That'd be cool. Yeah. I had to pay for it because it is his job, and I firmly believe in, if he has a service, I'm not trying to get this thing out for free, even though this is a free project I'm working on. I wanted to pay it forward. I want to make sure I'm paying someone for the service, for good services that they provide. So in this case, he went over a whole variety of things. Some of the things I've already kind of implemented, like the move constructor for the driver class. But one thing that he absolutely did not like was the fact that we weren't constructing our objects in the constructor. Well, I'm sorry, initializing our objects in the constructor. We had to have a two-phase initialize. And he was like, why do this? Like, that's why we have constructors. That's why they're so powerful. I'm like, yeah, you guys all might know my reason why we don't, initialize in the constructor. Mostly because of the fact that if you try to initialize in the constructor and you make global variables, you never know when each one of those will, like, you don't know the order in which they get constructed, and that could be a problem. And then I realized we came up with a couple options then. But one of them was, how about this? If you use get I2C like we have in a lot of other code, if you use get I2C, and actually let me just show you what that would look like. Let's go over here, go to here. I need to get rid of this. I'll do that later. That should be unpinned because this is more important to have laid up. I go over to upgrade and then go to demos. You gotta see it here. Okay. We have embed LPC get I2C 0. He says, how about this? How about rather than running initialize platform here, this runs initialize platform for you. And if you do need an uninitialized I2C, then you can have another function called get uninitialized I2C. The idea here is that, like, when you use get I2C, you automatically get something that's ready for you to use immediately. And if you really do need to get something that's uninitialized, you can run the uninitialized function, similar to how we have the uninitialized copy functions for C++ for 17 and 20. That way, like, we can skip out on this step here, skip out on all this actually, and then start using it immediately. I thought this was actually kind of neat. I like the idea and the approach to having two kind of, APIs for it. I'll go into more detail about that in the next section of the slides, but that's one of the big things that we talked about. We went through a whole bunch of other things, add W conversions, stuff like that. Add no discard everywhere where it should be added. Being very explicit about the fact that we should just say we don't use exceptions in our code, and and that anyone who uses our code should not like also use exceptions. Just make sure that's very clear. Just because like he told me that like if you're using exceptions and you don't put no except everywhere, there's going to be cases where things that don't have no except may throw an exception, and your code may generate a whole bunch of extra code around your code that can throw an exception, and that's pretty clean. It's pretty clean on GCC, but it's very dirty on Clang as that's his input, and they haven't like put as much effort into optimizing that. So that was that. A couple other little bits and pieces here that we went into. Some other things about Pragma and stuff like that. I'm making a whole bunch of issues for for everything that we went over, but I think one of the interesting things from this talk that I think is kind of going outside of the project is that he really found the utilization of virtual interesting, because he told me, he's like, most cases for C++ embedded programmers, they want to shove as much stuff into the compile time as possible, and hopefully just get like just a few assignments to registers and that's it. I said that works really well and that's really great and all, but when you want things to be flexible, virtual comes in really handy, especially if you try to compose very large systems, like for the robotics team, building up the robotic arm. We have a robotic arm that has joints, which goes to the classes, which then also has their I2C drivers and their GPIO drivers and a whole variety of other types and CAN drivers like that. And maybe you swap out one part from another part. It's important that what happens when you use templates or you try to use static polymorphism is that this stuff blows up size-wise. Every instance for every new instance of a class that takes a different type will create a new class. And if your optimizations or your compiler just doesn't do the best job of inlining everything for you, and maybe even times when it does inline for you, that's also a problem. If it inlines everything for you, you might be good, but you might also pay some cost there for size. If it doesn't inline everything for you, you get even worse size benefits because it gets even worse for you because you now have two separate drivers that do the same exact thing just with different types. So it becomes a problem. After I explained that to him, he actually found that approach to be really interesting and, similar to kind of like how Linux does it. And he wanted me to chat on the CPP Cast podcast. Just going to go over what I'm working on, this project, the endeavors, what I'm pushing to do, some of the features of this project, as well as just talk about, my approach to embedded and why I think this is probably the better approach, in my opinion, when it comes to size and, even when it comes to performance. Not saying it's better, I'm saying actually it's worse, but I think it's good enough. Actually, I think it's more than good enough. I think that people look at virtual as this heinous, horrible thing when it comes to performance. And I think in most embedded systems, that's perfectly fine. And if you've ever written an embedded system using C, and you've ever used a function pointer or a variety of function pointers, then you can't complain, in my opinion. So that's one of the things that we talked about, and that's actually one of the things that got him interested in having me on the CP cast. So I'm excited about that, and that's what we kind of came up to. And I believe we're going to be talking in 20 days from now, so February 22nd is when I'll be on the podcast. I'll give out more information about that when time comes. I'm excited. I'm also slightly nervous, but I'm really excited to talk about libembeddedhal, what we're doing here. I'm also going to very much preface that it's still in the works because no one can really use it yet. But I think this exposure and also just, having that conversation with him and Rob, the other guy who works on CPCast, would be really awesome. So yeah, that's my little meeting with Jason. Any questions on that? Cool beans. All right, so now the big part of today, the big part of this meeting is the new initialization model. And I'm not even saying like I don't have a new one. I probably should change this up to not new, but like it is going to be a new initialization model. It's a little hard to talk with my mouth as it is. So move away from the two-phase initialization to an automatic method. Basically use constructors in some way or shape or form, or just have some way such that the user and the code is automatically initialized by default. And here's the interesting thing about this. let's ignore all of the other edge cases and problems that can occur from this. Let's think about this from the point of view of drivers and what they do. If you eliminate, if it's assumed that when you pass a driver to, like, let's say an I2C driver to an IMU driver of some sort, like the MPU 6050, it is one of the things that you have to kind of do is you have to go in and initialize. Like, the idea of the previous model is that the lowest device in the tree, the lowest driver in the tree, runs initialize on its members, which then runs initialize on its members, which then runs initialize on its members, and keeps going down until you hit the bottom. Nice little tree structure. You can eliminate all that. I wouldn't say it's eliminating because you're still going to have it in your code, but you can eliminate any sort of checks to see something's already been pre-initialized by simply just when you get the object, you know it's initialized and start using it immediately. So there can actually be some space savings. Might be kind of minute, but I think it adds up over time. There might be some space savings in that assumption that that anything you get is automatically initialized and just go from there. The only case where this is actually, I think, a problem would be for CAN bus and UART, specifically because CAN bus and UART have baud rates, and those baud rates needs to be specific numbers, and also stop bits and everything else like that. Whereas with I2C, you have clock rate, and I think that's it. Is there anything else? I think that's it. For SPI, you have with SPI you have the number of bits, the clock rate, and some other information. I'm going to consider how that kind of folds into everything else as well. God, it really makes me want to remove the fact that you're able to change the number of bits for SPI. Actually, you know what? Actually, I don't know if that's actually true. SPI, I think I might have removed the bit length stuff because I just felt that it didn't make sense. And if you really wanted to change that, you can then change it in the driver itself, or like have some type of way to configure it from the driver's point of view, but not from like the virtual interface point of view. Where's SPI? There it is. There it is. No, I removed that. Yeah, you can only work with bytes. If you want to have bigger bytes, then you have to, like, you send an entire array of bigger bytes, and then the thing can concatenate them for you. But yeah, it's all in the driver. So yeah, this stuff here, most drivers won't even touch it. Like, they won't care what your frequency for your... Most systems aren't going to really care about your frequency that you're operating at. You choose that. An edge case of that would be the SD card driver, where it actually needs to change the frequency to a lower frequency, do the startup from there, and then bump it up to whatever else you were doing before. Clock idle's high, that kind of stuff. That's fine. So yeah, UART's the one where, like, if the baud rates don't match, then either that driver should set the baud rate to the proper baud rate number, or it should quit. And I'm trying to figure out what the proper answer to that should be. So his big thing was that we need to move away from the two-phase initialization because it's just error prone, and we've all known it's error prone. I can keep telling people, like, just don't mess it up, but like, I've seen robotics members mess it up. I've seen myself mess it up. I've seen other people mess it up. It's a problem. It's hard to keep right, and you'll see it the first couple times, but it'd be nice if you didn't have to worry about it, if it just worked. So we have a couple options here. We could have a constructor only. So on construction, it sets itself up. There's one massive problem with this, which is, what if you want to change settings? That doesn't work. Settings doesn't work. So constructor only is probably just not a viable option, just in general. And I think being able to change settings should be something that is available for drivers to be able to handle. So basically, it needs to be part of, like, the virtual API. It needs to be part of the polymorphic API. So that needs to be there. So this one's probably like a complete no-go. And there's a strike through here. Let's see if I can find strike through. Let's do format. Should be actually like what's the key combination? Shift. That's complicated. Command Shift X. Got it. Command Shift X. Cool. So yeah, constructor only just does not work. Now, what about factory functions like this here? This could work. This is the thing that we suggested before, is that get I2C would basically do the work of initializing for you. If you don't really know what that would kind of look like, it would basically just look like this, actually. Let me see if I can just get to it. Oops, daisy. Package or repositories, LPC. Let's go to include I2C, and then we have the getters here. Where are we? Oh, is it not in here? Okay. Let's move this over to upgrade. It should be here. That's not here either. Oh, I know where it is. It's above. It's above. It's right here. Okay. So here we have this little I2C bus definition. We have a static bus, and then which return the static object. In this case, what I just want to do a little edit here, is this. Just want to do this. Oops, daisy. I2C0 initialize, and that's it. So right when you grab it, initialize it. So that's one option. But like the only thing about this is that like if you do this, then potentially need to initialize twice the settings. But not gonna lie though, I think that's actually not that big a deal. All of our drivers are meant to be reinitializable, so you should be able to change settings whenever you like. And most of our drivers are rather quick when it comes to initialization. Very quick mathematic operations, and then a couple of assignment operations. So I don't think there's anything too bad here. Potentially there could be some weird race condition stuff if you do this inside of between threads. But also, like, none of this stuff's thread safe. It's not meant to be thread safe, so actually that'd be its own issue. If you were going to do this, you would need to make sure that you set everything up before you start your before you start your scheduler. So I wouldn't actually put that down as a problem. So there's that. Another option is just to make the constructors actually run the initialization function, and that's fine. And then if you want to reinitialize, you can there's the other initialize function you can run. But I think even better yet would actually be this down here, which is called reinitialize, with the idea that the constructor will initialize for you, and you run your reinitialize when you want to reinitialize. Make it very explicit what you're trying to do here, which is the object was already initialized once you constructed it. Now I'm going to reinitialize it with some new settings. So I'm thinking about this one. I like this one quite a bit, actually. Kind of my favorite at the moment. But there is one big caveat. This is the reason why I told him that we needed to do two-phase. The reason why I need to do two-phase is that what happens if you create a object that's global? You don't know when this constructor runs. The biggest concern here is if you have an I2C object and you make it global and it tries to initialize itself with a constructor, and you have not run embed LPC 40xx initialize platform, which initialize platform at the moment handles setting up timing, uptime, sleep functions. What's the other ones? Setting up the interrupt vector table, and then finally, what's the last thing we want to do? Set up interrupt vector table. More importantly, set up your clocks. Couple interesting things here. Number one, I was looking back at my old code, and actually, I think I'm gonna make this this is gonna be something I was gonna write it down as a standard, but clock classes, which are usually internal, so no one else usually needs to use them. They can, other users can use them, but no driver should use them. I'm sorry, no device driver should ever use them or care about them. But initialized platform are basically the clock configuration class needs to have members. It needs to be able to tell you on boot up before even configuring any PLLs or anything like that what the state of the system is. So if you ask, hey, what's my operating frequency, it should tell you, oh, it's 8 megahertz. So actually, the clock setup stuff is actually not even that big a deal. We can actually get around that because that's knowable at compile time. What's the word I'm looking for? All that information is knowable at compile time. That's what I'm trying to get at, is that um, this your board should tell you what your clocks are going to be set to when you first start up, and then you can change them when things go further. But let's say you're doing I2C, and let's say we decide that you have it globally set up, and I2C's constructor actually puts itself on the interrupt vector table. Well, we know that the interrupt vector table is a hard requirement for I2C to work. So why not have drivers that have hard requirements fulfill them? Like, call their dependencies. Thank you, Google Slides, for correcting my dumb spelling issues. So in this case, if you have a driver that requires interrupts, for example, I2C or UART, one of the things that's going to have to happen inside the constructor is that it needs to run the setup interrupt vector table and relocate it. Now we can actually put a check in there so that if you run it the first time, it'll relocate it. The second time you run it, it'll check to see if it's already been run, and go, oh, I was already running with the same interrupt vector table. Nothing's changed here. I'm not going to do anything. I'm going to move on from here. That way, you don't actually pay for actually relocating the interrupt vector table unless you use something that needs the interrupt vector table. So if you use I2C, UART, or CAN, or interrupt pin, all four of those, and maybe any other driver, all four of those will force invoke relocating the interrupt vector table. And if you use anything else, then you wouldn't have to actually worry about that, which would be interesting and neat. Same thing with the clock stuff. If the system needed to somehow define what its clock is at that point, it can run that. It can do that. The main issue here, look at my time, make sure I have time, cool. The main issue here is that, well, actually really there's no issue with that statement for the most part. That kind of just works in most cases. I have to look into how the initialization model works when you pass global objects into other global objects. I assume it actually orders them. But I'm not certain completely. So something to keep in mind. Okay. Next up would be, with this particular scheme, is that, let me think about this for a sec. What do you do when things fail? I am not certain what to do when things fail. It'd be really odd for any of the default settings for any one of these drivers to fail, but what happens when something does fail? And honestly, I am not certain. My first thought is just to do abort. So what happens if something fails? Std abort. Yeah, std abort, which just runs std exit. How do we know that it aborted? I'm not sure. Maybe we have... Yeah, honestly, I'm not sure, how we would go about doing this. Maybe for things that can abort, there's some sort of handler that, blinks an LED or blinks a line. But I think even then that's inappropriate, because what if someone wants to use that line for something else, and turning on that line turns on a motor or, something else that might be dangerous. So that part I am uncertain about exactly how to handle. I'm thinking that abort might just be the best option, and if you notice that your code isn't running, then you know that, okay, something went wrong. Probably one of my initializations didn't work, and in which case I'd probably tell people it's best if you just don't use global variables, because that problem can occur, where you just abort before you even start main. So that probably was going to be the pathway going forward, is what happens when a constructor cannot construct all the way, is that it aborts. Another reason why we do such a heavy, put down the hammer when it comes to this, is because it's better off to, when a peripheral doesn't actually work or a driver doesn't work, that's a hard failure. There's no way to really recover from that. So you should just abort from the program. Maybe even restart if there's some way I can attach that in as well.
A quick question. How do we know if a constructor doesn't work? Like, based off the self-test, if that fails?
Yeah, so it's the same way that we know that initialize didn't work. For example, let's say that you asked for a baud rate that's not possible. That's like, I can't, like, actually, let's look at two cases. Let's say we look at I2C, and for I2C, you want to have 2 stop bits, but the hardware does not support 2 stop bits. this is a setting that is something that someone requested that we cannot guarantee. And I think that the best option here, because most times when you ask for two stop bits, it means that you actually need two stop bits. Not like, oh, it could work with or without. It's like you need this thing to work with two stop bits. Therefore, you should throw an error at that point. If you throw an error during the constructor, you can get it out because you need to use exceptions for that. Therefore, it should just abort at that point. So, in the other case for UART, you have a baud rate, and that baud rate needs to be exactly that number. So let's say, the input clock to your UART is not high enough to achieve the baud rate that you need. Then we can just abort from there. That's kind of the idea. That's the case where a constructor or an initialize can fail. Does that make sense?
Yeah. Sorry, but I'm just thinking, can't you all those examples figure out at compile time as well?
No, because all this stuff is figured out at runtime. Hold on. You're saying like if you know that
Like
the
the
constants.
examples he gave me, I think you can figure out at compile time. So you would just have, I think it was the static exception, where like your thing doesn't compile.
Yeah. Let me think about that for a sec. So there's only one. So the thing is, so at runtime you can change your clocks. That should be something that you should just be able to do. So you can't know that at runtime. You need to have some type of error. You have some way to get the errors out that way. But you do bring up a good point. If the defaults, which are known at compile time, the defaults for all these different values are known at compile time. For settings as well as for like the clock rates the default clock rates are known at compile time as well. Therefore, if you ever create a global one of these objects, we just need to determine that you're somehow a global object, and somehow also determine that whatever the default baud rates are disallowed. I'd have to think about how to exactly figure that out, because you'd have to discern between whether or not the clock rates have been changed. Yeah, I'm not sure actually. I'm not sure how we would make that work at compile time. I see what you're going at though. I think that's a great idea to try to figure this out. What are you saying?
Yeah, I was just saying. Yeah, my point was like I think most examples like you can reject at compile time, like a function to call to change your clock rates for your driver. You can just reject that when you call the function, I believe. And that's when you try to call a function when you're writing your code and then compile it. Like the only case where I can see getting an abort is if your self-test within your driver fails.
Yeah, I think the main thing is that like yeah, I think the main issue is that like what clock settings you have, unless they try to come up with a way to make the clock settings somehow constant. I guess that's one thing, is that like should the clock settings be should the clock settings be constant and unchangeable? Because if I force that as part of the standard for any clocks, then you can come up with your own like clock system, like clock object, have that construct, and then you can actually immediately know whether or not that thing will work, and we can clear that up. We can figure that part out.
Yeah, okay, I see where you're coming from.
Yeah, so it's like because like the knowledge about about what the clock isn't it, like we know where it starts off at compile time. We just don't know where it is once the code starts running. Yeah. But I will dig into that a little bit further though, to see if there's any way we could figure this out at compile time. I would love to just figure out a way to determine whether or not your object is global in some way, or not put inside one of the not a static variable inside of a function. But again, I am not sure if there's a way to disambiguate between those.
I don't know if that's possible, because what if you have a program that wants one clock rate at the beginning, but then later on needs a different clock rate later? In that case, the clock rate isn't static and isn't knowable at compile time.
Yeah, and that happens. like usual start off at a certain number, you bump it up, and let's say you want to go into low power mode and you decide not to use sleep modes and stuff like that, and you want to bring down some of the clocks. I've worked on that kind of stuff too, so that's a thing. So yeah, it gets a little mucky.
Yeah. Okay. So I see that as a good use case for standard abort.
Yeah. So yeah, that's I think the easiest thing to tell people to do is like, yeah, if you can't do it, then just abort. That's probably the easiest guidance to get people to follow. Oh, any other questions or comments? Okay. But yeah, so that's kind of what I'm looking at right now. Is that would fit the global case, and then again, I would just tell people like just don't do the global case. Ignore the global case. Don't put things in global. Use things as they're intended to be used, and you should be good from there. And I guess there's one other fancy thing that I'm thinking about. Considering changes are like what happens when hard dependencies update. What I mean by that is like, let's say we change the clock rate. We change the PLL clock rate that changes the clock rate to the peripherals. What do we do then? And I thought like, okay, well in that case you just have to reinitialize, which is kind of annoying. That means like, if you initialize it initially and then you change the clock rates, what happens there? There are two ways we can go about doing this. Number one, do nothing, tell the person / user to set up clocks before creating any peripherals, or just peripheral / drivers. That could be one thing. Just the order of operations that you need to set up your clocks before you create any other objects, because they will immediately use those clocks. But when you change up things, problems occur. And actually, this is the problem before. Like, this was actually always a problem. I thought of another alternative. This is a little bit more complex, but I think it might be a good idea. Every driver that has a hard dependency on something like a clock, specifically where you can change it dynamically, like at runtime, must register itself to that clock. So the idea is, I'm gonna squeeze this in. Yeah. The idea here is that, let's say you have an I2C, UART, and CAN bus, and you use a couple of those. We have the driver interface, and we have the initialize function as part of the driver interface. So what we can actually do, and I had to make some slight changes maybe to the code to make this happen actually. But what you can actually do is, whenever you change the clock, reconfigure the clocks, it will automatically run initialize on all the other functions. I'm sorry, functions on all the other classes. So let's say you have I2C 1, UART 0, and then like a CAN bus, whatever. And then at some point down the line, you decide to change reconfigure the clocks. It will do the work of going back and reconfiguring all the rest of your other peripherals and making sure they're all good and they're all set up correctly. That way, the order in which you do initialization and construction does not matter. It'll always kind of make sure that everything's initialized properly. It handles all this stuff automatically. It's not as performant as doing it the right way, but it will always work. And if you ever realize that you want to make things better, you can make the change. That could be a little thing like, oh, go through this checklist, make sure you did things in this way, in this order, to reduce the time it takes for your application to boot up. That's an option. And I think that's actually not even too hard to add in. And it's not even that complicated. So I think that might be a way to kind of handle that. And now your code becomes super safe because you really can't mess it up at this point. If you grab an object, it's going to be initialized by default from its constructor. You can start using it immediately. And if you set up the clocks beforehand, cool, no worries. You'll use the new clock values. If you change the clocks like later on, no worries. It'll set itself up. And there's one last thing that you have to make sure you do, and that is, and this is probably the one area where you can shoot yourself in the foot. All this can't really be thread safe because trying to make this thing thread safe is actually a problem. If I block if you change the clock rates while the scheduler is running, not only does that muck up the schedule and it causes a whole bunch of chaos. Let's say that we can get it all to work. All of your threads are going to be deadlocked, waiting for everyone else to get swapped out. That might be a fast operation, but could also be a slow operation. And I think that it's in our best interest not to encourage people to do any sort of configuration initialization before the scheduler starts. It should happen before the scheduler starts, and make that a hard requirement. And if anyone gets outside that, then tough. Accept that your code's not going to work very well. So yeah, that's that little item there that I thought was kind of interesting today. What do people think about the new initialization model?
I'm still thinking of that
good.
last part.
Oh,
go ahead.
Oh, I just said I think it looks good. Go ahead. Sorry.
Oh, I'm just thinking about the last part. So,
Mhm.
if you make it a hard requirement to set your clocks before initialization, doesn't that make that feature of basically having a list? So if you change your clocks, it recalls initialization all of the other peripherals. Doesn't that make that feature a bit unnecessary?
Yeah, so the idea is to remove that requirement so that remove that requirement so that you have the linked list now, and now it doesn't matter which order you place them in.
Okay, sorry. So Mister, you want to remove that requirement?
Yeah,
Add it in.
yeah. My only requirement now is that you cannot initialize your objects in your threads. You can technically still do that, but I guess there's a couple things. One, you never change your clocks when the schedule started, because that's already a disaster ready to happen. Unless you're changing clock for a small domain, let's say it's an audio PLL, which has something I have to do at work. If it has to do something with audio, then yeah, that's fine, because you're not messing with anything that's outside of changing the peripheral clocks for all peripherals is a problem. Changing the peripheral clock for one thing that you're currently controlling, that's fine. So there's some leeway around that, but my main guidance would be just have everything set up before you run the scheduler, and then go from there. But no, that was a good point though. Anyone else? Maybe David. Any questions on anything from David? No questions from Okay. Yeah, I think we are pretty much at time. If you have any questions about anything we've talked about today, just put it on the Discord discussion channel. And yeah, thank you guys very much for coming along. A lot of cool stuff. Oh, what? Okay, yeah, a lot of cool stuff. I'm really excited about the progress, how this thing's kind of evolving and how things are kind of going with this. So yeah, no, I think I think that all the input that I've gotten is going to make this thing cleaner, better, more resilient to the future, and we're going to be making good choices in this. So yeah, excited. Can't wait for the next couple weeks, and I can't wait to have my CPP cast thing. So yeah, talk to you guys later.